All right, one more time. So we have x to the fourth minus x to the third plus x squared minus 3x minus 6, and we want to find the rational roots, and we're going to use the rational roots test and then synthetic division to determine which ones are actual roots. So finding our possible rational roots, remember that we're going to take the factors of the constant and divide them by the factors of my leading coefficient, which in this case is 1. So P, the factors of my constant, are 1, 2, 3, and 6. Those are all the factors of 6. And we'll call Q the factors of my leading coefficient, which is just 1 in this case. So I just have 1. So my possible rational roots are either the positive or the negative of each of P divided by Q. So 1 divided by 1 gives me positive or negative 1. 2 over 1 gives me positive or negative 2, and so on, positive, negative 3, or positive or negative 6. So these are all the possible rational roots, and now we'll use synthetic division to figure out which ones are actually roots. So remember, we're looking for a remainder of 0. If I get a remainder of 0, then I know I actually found a root. So I like to start with the smallest number, so I'm going to start with negative 1. And set up with just my coefficients. So I have 1, negative 1, 1, negative 3, and negative 6. Now bring down my first value, multiply. Negative 1 plus negative 1 is negative 2. Multiply. Negative 1 times negative 2 is in fact positive 2. Add. I get 3. Multiply. I get negative 3. Add, I get negative 6. Multiply, I get positive 6. Add, and we got lucky on the first shot, and I do have a remainder of 0, so I know that negative 1 is a root. So I'm going to hold on to this. I know that it's actually a root, and now I've reduced my quartic to the fourth power down to a cubic. I still don't really have a whole lot of methods I can use to solve a cubic, so we can use synthetic division again and try and find another 0, so we can reduce it down to a quadratic. Then we could use quadratic formula, factor, whatever. We have means to work with the quadratic. So let's try another one. I know negative 1 is a root. Negative 1 could actually be a root again, right? It could have a multiplicity of 2. So we could try negative 1 again, but I'm not going to. So let's go on and do positive 1. So I've broken it down to a cubic. So now I'm going to use this in my synthetic division to try and break it down one more time to a quadratic. All right, so I use negative 1. I'm going to go on to positive 1. And again, using what I have left over. So 1, negative 2, 3, and negative 6. Bring down my first term. Multiply. Add. Multiply. 1 times negative 1 is negative 1. Add. I get 2. 1 times 2 is 2. Add, and I get negative 4. So since I don't have a remainder of 0, I know that positive 1 is not a root. So I'm going to keep going. Let's try negative 2. All right, so I'm just going through the list. So negative 2. And again, I'm still using my cubic that we found. 1, negative 2, 3, negative 6. Bring down my first term. Multiply. Add. Multiply. Add. And multiply. And I obviously am not going to get 0. What do I get? Negative 28. Are we okay with that? So what does that tell me? Negative 2 is not a root, so get out of here. So I'm going to go on. Still got a couple more numbers in my list, so I'm going to try positive 2. So with positive 2, again, I reduced it down to a cubic, so I'm going to keep using that. Bring down my first term. Multiply. Add. Multiply. Add. multiply, got a remainder of 0. So I know now that positive 2 is also one of my roots. And now I started with something to the 4th power. After we found the first root, I'd reduced it down to a polynomial to the 3rd power. Now that I found my second root, we've reduced it down to a quadratic. And so this is x squared plus 0x plus 3. And now I can work with the quadratic and see if I get any pretty numbers back out of that, right? So let's take x squared plus 3. And how do I solve a quadratic? One way, well, obviously, set it equal to 0. And since I don't have a middle x term, I could just move 3 to the right-hand side. So subtract 3 from both sides. I get x equals negative 3. And then to solve that, I'll take the square root of both sides. So I get x is equal to plus or minus the square root of negative 3, which is plus or minus I square roots of 3. That's ugly all the way around. It's not real, and it's a square root. So this is very much so not rational. And all we were looking for were the rational roots. So the only rational roots to our quartic are x equals negative 1 and x equals positive 2. All right, so the wording's important. If we simply were asked to find all of the zeros or all of the roots, then we'd include these ugly ones right here. But since we were only asked to find the rational zeros, I just want the pretty ones, and so we're done.